and then to lane 2 is R2. And then they told us distances in the green. So we can see that the radius of lane 1, there we go. So let's see, this is example 5 on page 685. So we can see that now it's broken into the 2 circles, the rectangular middle. We have a radius for lane 1 and a radius for lane 2. So, and they tell us in the middle in the green, the radius of 1 is 29 meters, the radius of 2 is 30.25 meters, and then we can see the section that's labeled S is just going to be that rectangular portion in the middle. That S is 108.9 meters, okay? So to find the distance around lane 1, if you look at our formula here for letter A, my distance formula is going to be 2 times S, because remember, I'm talking about, I have 2 sides of S, okay? So that's going to be 2 times S, if this is my length S, plus 2 times pi times the radius of lane 1, okay? Huh?
How do you know to multiply 2S?
Okay, because if I'm trying to find the distance around something, think about perimeter. What do I know I'm doing? I'm adding, okay? So if I'm talking about perimeter, I have to add. So I know that if this is S and this is S, then I have 2 lengths that are S. Does that make sense? So now we said that we know that this is a semicircle and this is a semicircle. So if I just find the circumference of one circle, that's going to be in place of these 2 halves. Okay, so we're finding the distance for this figure and the distance around my curves. So I know that my first one will be 2 times S. So notice that S is 108.9 plus 2 times, one of the things that as I've been going through the practice in the book, to get your answers to come out with what they are in the book, they're not just using 3.14 for pi, they're using 3.1428. Okay, so that's what they're rounding pi to. So instead of just multiplying 2 times 3.14, you're going to do 3.1428. Good morning. Okay, now we've got to multiply that times the radius of 1, and the radius of 1 was 29 meters.
So you want to do the book the way they do it?
Well, I'm just saying that if you, I know that there's probably sometimes when you come up with an answer and it's maybe like a couple of decimal points off from what the book says it is. And what I realized is the book is using, you know how they usually go 4 digits after the decimal? That's what they're doing with pi. A final answer, they may round to the nearest 10th or 1 decimal place afterward, but typically when they're doing calculations, if there's more than 1 decimal, they're usually using 4 decimals or 4 places after the decimal in their calculations. Okay, so for lane 1, we have 2 times S, which is S here, plus 2 times pi times the radius of 1. And so we can see in the book, they multiply 2 times 108.9 plus 2 times pi times 29. And so that's approximately 400 meters. And then they did the same thing for lane 2. Lane 2, they have 2 times S plus 2 times pi times R2. R2 is 30.25. So that one is approximately 407.9 meters.
What is the 2 pi r the lowest? Like not lowercase.
Well, think about circumference is equal to pi d, which is the same as 2 times pi times the radius, right? So in this situation, I have 2 different radii being represented. So they said this is radius 1 and this is radius 2. So that's what this means here, is they're identifying, hey, this is the radius of the first one, this is the radius of the second one. Okay, so it's not any kind of special little, it's just saying that I've got 2 different radii. Okay, so the main thing there though is I'm using the same formulas, but I'm looking at my figure and saying, how can I break this into shapes that I know how to find distance of? I know how to find the distance of around a circle. So if I've got, so what would I do? What would I do if I only had 1/2? How could I find the distance of just this part and this? I just divide my circumference by 2. So I would still have my distance here and my distance here, but then I would find the circumference of a whole circle and then just divide by 2 and then add them together. Okay? Now, the question is, if you're a runner and you're in a race, which lane do you want to be in? Why? It's the shortest distance. Okay? So think about, so when you're looking at a track and you're looking at races, obviously the runners, everybody wants to be on that inside lane because that's the shortest distance. Okay, so I wanted to make sure that we went over that because I know we kind of flew through that yesterday. So I wanted y'all to understand why it was what it was. It said to find the distance around it. We can see our straight path. We have to have 2 times that. My 2 semicircles make 1 whole circle. So I have my distance around my rectangle plus my distance around the circle is my total. Any questions on that? Now, I will tell you that you're going to need to use this example on number 31 in the homework for this section. Look at number 31 on page 687. Look at number 31 on page 687. Oh.
Wait.
What do you see your straight segments are? 5. How many do I have? 3. So if I'm looking here, what would this first part be? How many sides do I have? 3. And this one I had 2. So in number 31, you're going to have 3 sides. And what are each side measure? 5. So 3 times 5 is 15. So now we've got those straight side measures. But how many curves do I have? 3. And each one is a third of a circle, right? So if I put all 3 parts together, what do I have? 1 whole circle. Okay? So when you're looking at that problem in your homework, you've got your 3 straight segments. So you're going to multiply 3 times 5 for the straight segments. But then notice that each of the curves, the one that comes up here, the one that's down here, and the ones that's down here, you've got about a third of a circle for each part. So if I put all 3 of these together, I've got 1 whole circle. Okay? So you'll need to just look at that to be able to solve. So I wanted you to be able to see this, how we went through this, to be able to help you for number 31. That you're
32, 31?
Well, we only have to do odds, but in 32, what would you have to do? How much of the circle is sectioned out? Look at each circle. Look at each figure. So it looks like roughly like that. So basically, if this was a whole circle right here, notice that it's only this part that's missing, right?
Yeah.
So each corner is missing. Each corner is missing a fourth of the circle. So what if I put all 4 of these together? What is it going to make? A whole circle. So in this one, I'm going to have to find my whole entire distance, but then I'm going to have to subtract circumference because I'm taking it away, okay, because it's missing. All right. But like I said, and what would you have in 30? What would you have to take away from that rectangle?
2 halves.
2 halves, which makes how many circles? 1 whole circle. So basically in 30 and 32, you're finding the distance of the entire figure, assuming that the missing segments were there, but then you'd have to find the circumference of the circle and subtract it from the total. Okay. All right. So homework on this section was numbers 15 through 35 odds and number 53 through 61 odds. Okay. Okay, so look at 33 and 35. Okay. 33 and 35 are going to apply to numbers 20 through 29 odds. Notice on number 33, look back at example 3 on page 684. Go to 684, example 3. Blue one for sure did not rise very well. Okay, look back at example 3, look at letter A. Notice that we've got the formula where we have arc length over circumference, 2 pi r, is equal to the measure of the arc over 360. Okay, so looking at letter A, we have the length of the arc, which is 3.82 in our numerator, over 2 pi r is equal to the measure of PQ, which is 60 degrees, over 360. Okay, I cross multiply and solve. So notice they've already told me my inner measure is 60 degrees and my arc length is 3.82. Look at letter B. Letter B is telling me to find the arc measure. So they've told me that my length on the outside is 18 inches. So again, they put 18 in the arc length over 2 pi r is equal to x, my unknown measure, over 360. And I cross multiply to solve. So notice when I'm using that formula, that's what I'm doing in numbers 33 through 35. So I'm plugging in the pieces that are represented by variables into this equation. So what we'll do, let's go ahead and look at 33 for a minute. Using this formula here in number 33, what is my arc length that they've given me in 33? Y minus 3 times pi. Oh, I'm gonna mess that up. Okay, over 2 pi r equals.
2x plus 15.
All right, so let's look at that for a minute. 2x plus 15 degrees, right? How many variables do I have in this equation? So I've got to solve for one of my variables before I can solve this whole thing. So now let's go ahead and look at that x value. If I have 2x plus 15 is equal to, what is the interior, or what's the rest of my arc measure?
8.
If this is 225, and I know this part is 2x plus 15, okay? If I know my whole circle is what on the inside? What's my total measure? 360. What is this measure right here? 225. So how can I figure out what this measure is? What's 360 minus 225? 360 minus 225, 135 degrees. So if I know that 2x plus 15 is equal to 135 and I need to solve for x, I know 2x plus 15 is equal to 135. So now I'm going to subtract 15, 2x is equal to 120. So what does x equal? Why did I divide by x? Divide by 20, and x equals what? 60. Okay. So when I set this up and I said, wait a minute, I've got a variable y and I have a variable x. I cannot have two variables in the same problem. So I looked at the problem and said, hey, to find x here, I need to find what my angle measure is over here. So now that I know this is 135, it's going in up here. So now I can plug in 135 up here. So we've already found that x is equal to 60. So now we need to solve for y. All right. When I have proportion, how do I solve? Cross multiply. Okay. So when I cross multiply.
Should you distribute first or do you?
Okay, let's talk about that. Let's go ahead and use, like I said, for pi and doing these calculations, this is when I figured out they're using 3.1428. So basically, I'm going to go ahead and distribute this. And so I'm going to have 3.1428y times 3.1428 times -3 is going to be -9. Oh, I need a minus sign in there. Minus 9.4284. And I'm going to multiply that by 360 over. No. Over, because I'm cross multiplying. So basically, I've distributed my pi to each of these, and that's how I've ended up here. That's where I distributed pi. Now, I have to multiply it by 360, so I've got my 360 out here, equals 2 pi r times 135. Okay? But what does it tell me in my problem that r is? 8. So if r equals 8 and pi equals 3.1428, I'm going to plug those in. So 2 times 3.1428 times 8 times 135. Does everybody see where these measures have come from? I distributed pi first as a decimal, and that's how I ended up with these numbers. Then I'm cross multiplying 360. So now that means I've got to distribute 360 to each of these numbers. Okay, so 360 times 3.1428y is going to be 1131.408y is equal to minus 3394.224 is equal to, then when I multiply 2 times 3.1428 times 8 times 135, I get 6,788.448. Now I have it in a workable equation. What am I going to do first? Add 3394.224 plus 3394.224. So I'm going to have 1,131.408y is equal to 10,182.672. Now what? Divide by 1131.408, because remember our goal is to solve for y. 1131.408. So y equals, after all that,
2, 3.
9. Okay. So, but I started out with the exact same formula that I'm working with. So you're going to do the same thing on number 35. You are using this formula. All we did was plug in the values that they gave us. Okay. So we did have to find the measure of our arc. The way we found out was knowing that our total was 360, subtract the portion that they gave us. So we were able to set up that to, whatever it was, 2x plus 15 equals 135. So we were able to find for x, and then y equals 9. Okay, so you will do the same thing for number 35. Start with your formula, plug in what they give you, look to see what you need to solve for first, and then go. So look at number 35. What are you going to have to solve for first? I'm going to have to solve for x first. And what do I know 18x is going to equal to? 315 is the big open part. I'm trying to find the little part. So what did you say it was?
45.
45. So I'm going to say 18x is equal to 45. I'm going to solve for that first. Then I'm going to plug in. Okay. All right. Moving along to 11.5, page 691. 691. Okay. So it says the diagram below shows regular polygons inscribed in circles with a radius r. Exercise 42 on page 697 demonstrates that as the number of sides increases, the area of the polygon approaches the value pi r squared. So basically, this is where they're introducing the area formula of a circle, and the area of a circle is pi times the square of the radius, or A equals pi r squared. Okay, so the area of a circle, area equals pi r squared. So in example 1, find the area of circle P. What is my radius of circle P? 8. So I'm going to have 8 squared is 8 squared. 8 squared is 64. So I'm going to multiply 64 times 3.1428. And that's how they ended up getting approximately 201.06. Pi times r squared. Letter B, find the diameter of circle Z. All right. So look at circle Z. What have they told us? Well, okay, we can see a diameter, so that's what we're trying to find. But what other information do they give me? They give me the area is equal to what? 96 centimeters squared. So I know that pi r squared is equal to 96 centimeters squared, right? So I'm going to divide by pi, 3.1428, divide by 3.1428. Say again? 30.56. Is this one of your things where you're just guessing or you're actually calculating?
I'm right.
You're right.
I'm looking at a book.
96 divided by 3.1428. So we have r squared is equal to 30.546. See, that's what I never get. Because realistically, if we rounded that by using 3.1428, 3.14 times 96 divided by 3.14, now is 30.56. No, it's 30.57. So 3.14 times, or not times, what I keep, 96 divided by 3.14 is 30.5732. 96 divided by 3.1428. 3.1428 is 30.546. So neither of them are getting the 30.56 that the book has given us. So just know that if you use 3.14, I will do calculations according to that as well. And as long as you're using one of these values for pi, I will have the corresponding answers to go along with whichever one. Okay, so the book is not very consistent on what they're using. So anyway, all right, so we know that 30.546 or whatever is r squared. So how do I find r? I've got to take the square root of both sides. So to find r, I have to take the square root of 30.546, and they have said that r is approximately 5.53. So I know that's the radius of my circle. So if that's the radius, then what is the diameter? 11.06. Okay, remember my question asked for the diameter. So I would multiply 2 times 5.53. And so my diameter is 11.06 centimeters. Okay, so remember when you look at your questions, look at the question, what it's asking, make your plan on how to set up the problem, solve it, but then when you've solved it, go back and say, did I answer my question? If I would have just stopped at radius and I didn't answer the question was the diameter, then you'd have a wrong answer on the test. Okay, so make sure when you look at your final answer, look back at what the question is asking. Did I answer the question? All righty, turn to page 692. It says a sector of a circle is the region bounded by two radii of the circle and their intercepted arc. So when I'm talking about a sector of a circle on page 692, I can see that I'm talking about that blue section.
That's our bullet point, right?
Probably, I don't even have my notes out.
That's why I asked where I was like.
Yes, so your bullet point 2, a sector of a circle is the region bounded by two radii of the circle and their intercepted arc. In the diagram, sector APB is bounded by radii AP and radius AP and radius or segment BP and arc AB. The following theorem gives a method for finding the area of a sector. So a minute ago, we said the area of a circle is pi r squared. Now we're looking at the area of a sector. So the area of a sector of a circle is,
Can I go to that?
you may, the area over pi r squared is equal to the measure of the arc. And so what I'm doing is, instead of naming it AB, because you might be working on a different circle and it may be named something differently, it could be PQ, whatever. So that's why I'm just going ahead and putting the word arc, okay, over 360. Okay, so A over pi r squared is equal to the measure of the arc over 360. Now notice they give an alternative formula to where you can say area equals the measure of the arc over 360 times pi r squared.
Mark the arc.
Okay. Just remember M arc means measure of the arc. Okay, or mark.
I will never.
Mark over 360. Okay. So you can see those two formulas I put there after theorem 11.8. You can use either one, plug in what you know, solve for what you don't know. So that's what they've done in example 2, finding the area of a sector. It says find the area of the sector shown at the right. So look at our sector. We have the sector that goes from PC is 4. So what does that mean from P to D is? 4. And what is the measure of my arc? 80. Okay, so you can see that in the book they use this formula. So what I'm going to do is I'm going to plug it in using this one so you can see it does the same exact thing. So A equal A over pi, what's my radius? 4. Pi times 4 squared is equal to, we said our arc is 80 over 360. Okay, so I'm going to have A over pi, which is, we'll say 3.1428 times 16 equals 80 over 360. So now I'm going to go ahead and multiply. I will cross multiply here. And I'm going to have.
I'll say it's going to equal 11.20. Well,
So I've got 3.1428 times 16. So I'll have 360 times A is equal to 3.1428 times 16 times 80. So 360A is going to equal, so I've got 3.1428 times 16 times 80 equals 4,022.784. Divide by 360, divide by 360.
11.21.
This comes up with 11.174.
Oh, no.
So notice in the book, they said approximately 11.17.
Oh, I was 0.4 off. Huh? I don't get the book, it'll close, right?
So notice they plugged in using this formula. We plugged it into this one. For some reason, I like this one better just because it's a little more compact. This one just stresses me out a little. I don't know why. So just go with whichever one you prefer, which one is easier for you to remember, because they're both going to work out the same. We found that the book used this one and got 11.17. We use this one, got the same thing. So either format of the formula will work. Let's look at example 3. A and B are 2 points on circle P with a radius of 9 inches, and the measure of angle APB is 60 degrees. Find the areas of the sectors formed by angle APB. Okay, so you can see here they've plugged in the formulas. So notice that it's finding, I now have to find the area of both sectors. I'm having to find the area of the red sector and the area of the blue sector. Okay. So let's go ahead and take a look at how we would do that. Okay, so it says to draw it. So if they didn't give you a picture to use, then it would help to draw it. But since they've given us a picture to use, we can go ahead and have that. All right, so I see that the measure of my angle is 60 degrees. So that means the measure of the arc is what? 60 degrees, because it is a central angle. Remember, my central angle and the corresponding arc are going to be equal to each other. Okay, so if it's a central angle, then my arc measure is the same. So when I'm looking here, and I've got area over pi times, what was my radius of this figure? 9. So I've got pi times 9 squared is equal to, what is my arc? We said it was 60 over 360. So again, area equals 3.1428 times 81 times or equals 60 over 360. Cross multiply. 360A is equal to 3.1428 times 81 times 60. Let's see what that's going to be. A big number.
A big boy number.
Let's see. 3.1428 times 81 times 60 equals, so I've got 360A is equal to 15,274.008. Divide by 360, divide by 360. A equals 42.4278. So we'll say approximately 42.43. Take a break.
Awesome. You know, me and my friend were talking about how did you think about how come we're millionaires? And we
I overslept. I set an alarm for 7, and then I got up at 8:30, and it was like, but I lived about 5 minutes. Yes. Oh, okay. Drop it.
how many you say? All right. Start down. How many push-ups? Start go. 1, 2, 3. 4, 7, 5,
6, 7, 8, 9, 10. There's somebody dropped you on. Come on, go, go, go. 14, 15, 16. I can't read this thing now. 17, too bad. 18, 19. Wait, what? Oh, come on, 1, 2, 3, 4, 5. All right, I'm ready to go 5. I'm putting to sleep.
Is the test due this week or next week? I mean, next week.
You can think
or
about it.
later.
Well, I won't give it out until next week.
Oh,
Yeah, because so we'll try to get as close as we can to finishing the chapter today. We should be able to finish 11.5 and 11.6. So that means that next Wednesday we would start with the chapter review, and I'd give y'all the test on Wednesday. Then it would be due the last week of class.
This is my last page from my notebook.
Oh, yeah.
And this is my second notebook.
I know. But you know what, if we did just go ahead and say, okay, have a nice holiday.
It wouldn't work. We would become millionaires.
Yes, he was.
Cereal flavored milk would make us millionaires.
Me and Garrett were talking about football, and he brings up the cereal flavored milk again. I'm like, what?
Yeah, like we kept on having good conversation, and Easton would be like, "What about the cereal flavored milk? What about the Lucky Charms?"
That's a good one.
A kid would be walking along and his his mom would go, "Mom, we'll get the Lucky Charms on." And then just go like, be a cycle of little kids going.
Did your parents get you what you wanted at the grocery store when you were little?
Yes.
I always like wanted that, and my mom was like, "Get the Walmart brand." Like,
Okay, so I'll tell y'all a funny story. I know I'm full of stories.
It was a rule where.
There's no story.
It
So
was a rule where
y'all talk about that, and it's funny because we have this discussion all the time about how like our kids like basically. So I guess there's different levels. Like my sister's kids, like when you say get whatever they want, like they get whatever they want. Like one of them, they were at Costco, whatever, and there was a gaming computer And my nephew's like, hey, mom, can I get, or no, hey, dad, can I get this? Ask your mom. My sister goes, I don't care. Like $1,200, gaming laptop. It was a gaming, a gaming laptop. So like when I say my sister's kids get whatever they want, like literally they're at Costco, hey, can I have this? Sure. Okay. You know, so they literally get whatever they want. We always kid and tell my kids, like, y'all get whatever y'all want, but they know that like they really don't. But it's the same thing. If there's a Walmart brand, we're getting Walmart brand. Why are you going to get that? So anyway, as a joke, I got this. Was it for my birthday? A pack of 3, because this is what we used to ask for when I was little.
Yeah.
Like, mom, can I get the multicolored pen?
Okay.
And no, you could not, because they were too expensive. And I always managed to break mine anyway, because I would tighten it too tight and then the plastic would crack or whatever. But anyway, so it was a joke, because so my husband got me a pack of 3 for my birthday with all my birthday stuff. So anyway, and the kids were like, that's lame. So we were laughing though, because it had been like on a 80s kids Facebook page or something about like, you knew you were big time when you had the multicolored pen. And so it's funny. So that's what we always tell our kids. Like when we were little, we couldn't even have this. I mean, think about all the mess that y'all get, your $100 and something shoes and your whatever it is that you
No.
get.
But
Like,
Sean
no.
was walking down-
We only wanted a pen. Okay. Who is that? Is anybody
What
looking?
was his name?
Huh? Somebody looking?
Whatever his name
A
is.
big old tall guy with lots of hair.
Yeah, what was his name?
Wait,
Somebody looking for somebody in here?
Nick Cruz?
Yes.
Cruz.
I guess so.
I think it was Cruz.
Okay, so anyway, so that was my little story about, you know, y'all think y'all don't get what y'all want. Like I couldn't get a multicolored pen when I was little.
Like every kid should get Walmart brand, cause like I was raised like that.
Yep.
And now I know how to save money.
Well, and the whole thing is a
Like
lot
it-
of times the Walmart brand is exactly the name brand.
Oh,
But
yeah.
like, I know when my kids were little and we went on a field trip at Golden Flake,
Uh-huh.
I think it's Publix, that they have the plastic wrappers for the Publix brand's chips and the Golden Flake chips. And the same chips go in the Publix brand that go in the Golden Flake brand. So usually it's the name brand thing, but the store brands they pay the company to put it in their wrappers and then they sell it for cheaper. So it's the kind of thing, a lot of times the store brand stuff is exactly the same thing as the name brand and it's cheaper.
That Walmart cereal is probably better than the actual.
So anyway,
Like sodas, like.
Dr. Thunder.
Oh, yeah. No, but they're all the exact same soda.
Yeah. Yeah, so a great little money saving thing, buy the store brand. And then if you don't like it, then buy the name brand, but at least try it.
You always get the all you
Yeah. Yeah.
Imagine that.
Yeah. Not the same.
The Oreos.
What the heck? You gotta choose.
Yeah, Oreo and Hydrox are not the same. Okay.
Yeah, but the butter, the Walmart butter.
Oh, yeah. All right. Back to math. Yay. Okay. So we just found what it would be to find the sector of the red. Okay, so to find the sector of the blue, we're doing the same thing, but what's the only thing that's changing in this whole equation? What is the only thing that's going to change to find the sector of my blue? This measure right here. Okay, so to find the blue, what is my arc measure? 300. Because the red, I'm dealing with only 60 degrees. My radius is the same. My formula is the same. The only thing that's changing is my arc measure. Okay, so looking at these, and so you can see the area of the larger sector, they've changed from 60 to 300. We still have times pi. We still have times r squared. So we can see the bigger sector is 212.6 square inches. Any questions? Goal 2, using areas of circles and regions. You may need to divide a figure into different regions to find its area. The regions may be polygons, circles, or sectors. To find the area of the entire figure, add or subtract the areas of the separate regions as appropriate. So looking at example 4, find the area of a region. Find the area of the shaded region shown at the right. So notice the shaded region is only the little blue part. So I've got to find the area of my circle. Then I have to find the area of my 1, 2, 3 hexagon. I have to subtract the area of the hexagon from the circle, and that gives me my area of my shaded region. I will tell you there are questions like this on the ACT. So where it'll show the area of the shaded region, where you have to know how to calculate the area of the two objects and then be able to subtract out what you don't need. Okay, so what they've shown here is the area of the shaded region is equal to the area of the circle minus the area of the hexagon.
Was that I was asking 5 to the problem.
What is the 5?
Problem.
Mm-mm. What is the 5 in this problem? Remember, it goes through a vertex in this. So
In the book, it says the apothem.
the apothem,
What a save. I caught it in the ground.
says the apothem of a hexagon is 1/2 of the side length times the square root of 3. Okay. So in this situation, it says the diagram shows the regular hexagon inscribed in a circle with a radius of 5 meters. The shaded region is the part of the circle that is the outside of the hexagon. And so area of the hexagon is 1/2 the apothem times the perimeter, but it doesn't say. I'm wondering if that 5 meters is actually supposed to be the red segment.
It's supposed to be both the radius and the apothem?
Well, I guess what they're saying is that it's the side length as well. So I guess it's hard to tell on that one because I don't know if the 5 that's labeled, well, no, the 5 that's labeled on it should be the radius because that's part of the solution.
I'm doing the problem.
But I'm trying to figure out how to know. So if the radius is 5, the diameter is 10. But they do not tell us exactly what the side length is. So I don't see how we're supposed to infer that if this is 5, that this is also 5. Oh, how would we do that? So think about if from my center to this edge, if they've told us my radius is 5, and this is my, let's see, how can I draw this? I've got, well, my drawing is not my gift. Oh. Oh, we'll pretend like that's. Okay, so if that's 5, what is that going to be? Well, but notice that if I went from vertex to vertex and that's 5, and I broke it in half, then I could say, all right, there's my right angle. I could look for my angle measure and I could be able to figure out. And so it ends up being that because these are all making equilateral triangles. Remember, it makes regular triangles. So a regular triangle, if this is one of my sides of my triangle and it's 5, then that means this side is 5 and this side is 5 because they're regular triangles. So equilateral triangles all have the same measure. So that's why my apothem is going to be half of my apothem is going to be 5 because of it being irregular. And that's what we had to conclude based on the side lengths being congruent and my angles being congruent. It's a regular hexagon, which means when I break it into triangle segments, they're all equilaterals. Okay. All right, look at example 5, finding the area of a region. Woodworking, you're cutting the front face of a clock out of wood as shown in the diagram. At first I thought it was going to be a cornhole board, but then I was like, man, that hole's really big. Like, I think that'd be kind of cheating. So, well, I mean, like, and if I was just looking at the, Anyway, I wasn't looking at the numbers. I was just looking at the picture.
That's little people.
That would be. You're cutting the front face of a clock out of wood, as shown in the diagram. What is the area of the front of the case? Okay, so we've got to look at the front of the case. So notice in this picture, notice that we are able to break it into a rectangle. Let's see how this goes. This is not going to be perfect. Okay, so we can see though that I can see this is a rectangle on the outside, and it tells me that this is 4, so this is 4. This is going to be 5.5 inches, so this is 5.5 inches. Okay, so I can see that part. I can see that from here to here is 3.5 inches, or no, just 3 inches. Okay, so I can take my area of my rectangle, my area of my sector, and then I've got a semicircle or half of a circle. So the area is equal to the area of the rectangle plus the area of the sector minus the area of the circle. Okay. So it says, so we just plug in the numbers there and find the area of the front of the case is about 34.57 square inches. All right, let's look at 694. Complicated shapes may involve a number of regions. In example 6, the curved region is a portion of a ring whose edges are formed by concentric circles. What are concentric circles? Concentric circles. That's a vocabulary word from several chapters ago. What did we learn about concentric? Okay. What is the word, the part sin, not S-I-N, C-E-N. When I say concentric, center. Okay, so I'm talking about concentric circles. Look at my figure at the top of 694. It's 2 circles that have the same center. Concentric circles are 2 circles that have the same center. So it says, notice the area of the portion of the ring is the difference of the areas of the 2 sectors. So basically, to find the sector that is shaded, I would find the area of my whole figure, the area of the smaller, and just subtract them. But now we're talking about just sections of my circles in example 6, dealing with the area of a boomerang. I've never been able to figure out how to throw a boomerang. Not that I've really tried that much, but. All right, find the area of a boomerang shown. The dimensions are given in inches. Give your answer in terms of pi and to 2 decimal places, okay? So it says, so if we look at it, we can see that each section beyond the curve is 8. So each section beyond the curve is 8. And then notice I've got, not only do I have the sector in the middle, but I've got curves on both ends. So those curves on both ends can make, when I put them together, that would be one solid circle. But then I have to break my arc up. So we can see in the book, it says it's helpful if you draw it out. So you can see here that we've got the whole figure. We've got semicircles at each end. We're able to break apart our rectangles for our sectors. And then we have our curve, or we have the.
Could you draw on the board? Could you draw on the board?
You're just making fun of me, aren't you?
No.
You're either trying to get me to waste time or you're wanting to laugh at my drawing. Which one are you doing? One or the other. It's drawn right here in the book. Why do you want me to draw it on the
Okay.
board?
Let's tell this one.
I've messed this one up. Good. Okay, so we can see in the picture where it says there are 2 semicircles on the ends. So the 2 semicircles put together would be one circle. So I can find the circumference of the whole circle. I've got my 2 rectangles and I can see that they're 8 by 2. So I can see that for each of those, to find the area, I would just multiply 8 times 2, which is 16, and then 16 times 2 is 32, because I've got two 16-inch parts. Then I've got to find the portion of the curved part of the portion, and we can see that to make it intersect, I can see that if it intersects at a right angle, I've got 4 inches that is not included, so and 6 inches total. So the area of the boomerang is equal to 2 times the area of the semicircle, or actually 1 times the area of the whole circle, plus 2 times the area of the rectangle, plus the area of the portion of the ring. So to find the semicircle, we find 1/2 times pi times the radius squared. So that's going to be 1/2 times pi times 1 squared, which is going to end up being 8. Then I have to multiply 8 times 2, which is 16. I'm sorry, no. Which we'll have to add, we'll have to multiply that by 2. 8 times 2 is the area of the rectangle, but remember we said we've got 2 of them. And then the area of the portion of the ring is 1/4 of pi times the radius squared minus 1/4 of pi times 4 squared. Why am I subtracting the 4 squared portion? Why in the equation for the area of the portion of the ring? I have 1/4 times pi times 6 squared minus 1/4 times pi times 4 squared. Notice that in the drawing, the 6 squared includes the white section and the boomerang. The 4 is only the white section. So I've got to subtract out the portion that is not included in the boomerang. And so that's what they've done. So we can see through the process, they've calculated it out. And so they said with the answer to represent it in the directions, it said, give your answer in terms of pi and to 2 decimal places. So the answer, you've got 6 pi plus 32. So when you end up multiplying 6 times 3.1428 and then add 32, you've got 50.85 square inches total. Okay. So the main thing though is to break down a figure into parts that you know how to calculate the area of. We know how to do the area of a circle. We know how to do the area of a rectangle. Okay, so that's all you're doing. And now we've learned how to do the area of a sector. 695 guided practice. So number 1 says, describe the boundaries of a sector of a circle. What did we say the boundaries are? Good, 2 radii and their intercepted arc. Very good. So when I'm talking about the boundaries of a sector, I know I'm going to have the 2 radii and then that arc that's being intercepted. Okay, so thinking about like a piece of pie. In example 5 on page 693. Example 5, page 693, explain why the expression pi times 1/2 times 4 squared represents the area of the circle cut from the wood. So it says, explain why the expression pi times 1/2 times 4 squared.
It's diameter. Right? Or no?
Because 4 is the diameter, right? So what is the radius? 2. Yeah, so that's why. So because the radius is 2, that's why you're doing half of 4 because it's actually 2. All right, look at number 3. In exercises 3 through 8, find the area of the shaded region. How am I going to find my area in number 3? What's the area of a circle? And what is my radius?
9
9. So this is what, number 3?
equals 3.142.
Area equals 3.1428 times 9 squared. What is 9 squared?
81. I got this.
What you got?
254 5668.
254
5668.
What'd you multiply pi as?
3.1428
Times 81?
2.545668.
They have 2.4.
Let me try 3.14. 2.54.34.
And the book has 2.5 or 254.47. So they've got it in between.
Wait.
Let's see.
3.142.
Yeah, try that.
Wait, what did you say it was? 7.
Um,
I got 254.502. Math pretty good.
say that 2.54.47 is what the book says. But the main thing is, as long as you're pretty close, you said 2.54, what was
5668.
5668, so we would round that to 57. So anyway. All right, number 4, how am I gonna set that up? What am I gonna multiply?
3. A equals 3.1428 times 3.8 squared.
Okay, what is 3.8 squared?
14.4.
And then what are you gonna multiply that by?
3.1428. 45.382.032.
Okay. Number 5. What am I gonna have to, if it's pi r squared, they've given me the diameter in number 5. So what is my radius in number 5? 6. Remember, they've given me my diameter. I need the radius. So I'm gonna have to divide 12 by 2. That gives me 6. So I'm gonna have 2 times pi, not 2 times pi, good grief. I'm gonna have pi times 6 squared. 6 squared is 36. 36 times pi is gonna be approximately 113.1.
113.1408.
Okay.
Oh yeah, it's more 5 around.
Number 6, how am I gonna find the area of my sector that's shaded? What's our formula here?
Oh, so you know that the radius is 6 squared.
We can see that our radius is 6, but what is our formula here?
Equals mark over 360.
Okay,
Yeah,
so,
it equals mark over 360.
yep, mark over 360. So area is equal to 3.1428 times, what's my radius?
6 squared.
6 squared is equal to, what's the measure of my arc?
110.
110 over
360.
360.
368.
So I'm gonna have 3.1428
Okay.
times 36. Then I've got, what's 3.1428 times 36?
113.1408.
113.1408.
1408.
And then we're gonna have to multiply that by 110. So what is that times 110?
Whoa. 12,445.488.
Equals to 360A. Divide by 360. Divide by 360. So what does A equal?
34.5708 or 34.6.
You said 5.7, so 34.6. And is it feet squared? Okay,
Yeah.
so remember, so in the first section, we were just using area of a circle. In this next section, we're using the area formula where we're doing the sector. Okay,
When will we use as in the other problem, we did 360 minus 110 and then that over 260. So when will we use that?
which one are you talking about?
In example 3, we then plug in 300 over 360. When would we? Oh, when it's larger sector.
Yeah, so that was when we had 2 different sectors that we were finding. Okay, so let's go ahead and take a look at our homework. In this section, we have got numbers 11 through 29 odds. So go ahead and look at numbers 10 through 14 and 10 through 18. It says find the area of the shaded region. What formula am I going to use for number 11?
Area equals pi times r squared.
Pi r squared for number 11 because I'm just trying to find the whole circle. What about for number 13?
Diameter divided by 2.
Okay, so diameter divided by 2, and then, so now I found my radius, and now I'm just going to use area equals pi r squared. For number 15, which formula am I going to use?
Area over pi r squared equals the measure over 360.
Good. So, bless you. So that's going to be number 15. You're going to use that calculation. Look at number 17.
Oh, what?
Look at number 17. What do I notice about each of those, the center arcs? They're all congruent because they've all been marked with the single red congruence line. What do I see that the radius is?
4.6.
So it's my radius of my other two.
4.6.
Okay, so I know that for my shaded region, I can see that my 2 radii will be 4.6. What do I know that my arc measure is going to be? 360 divided by 3, so 120. Because they're all congruent, so 360 divided by 3 will be 120. So in number 17, they're expecting you to know how to find that measure of the central angle. Now look at number 18. What are my radius measures? 8. What is my arc measure? 125. And how many sections do I have? 2. So once I use this formula and find one of them, whatever my number is, I'm going to multiply by 2.
18. You're doing 18.
Oh, no, you're not. But if you did, that's what you would do. Look at number 19. What is the area of a circle with a diameter of 20 feet? Pretty straightforward. Okay.
So you just, that's easy.
Yeah, just half the diameter. Pi squared.
Radius.
Number, page 696, we go through 29 odds. And so number 21 says find the radius of circle C. So we're trying to find the radius. They have given us the area and they've given us the arc measure. So I'm going to plug in my area. I'm going to plug in my arc measure, and I'm trying to solve for the radius. So remember in my formula, I have radius squared. So I'm going to need to take the square root to find my solution. Numbers 23, or look at number 23. How are you going to solve 23?
Yes.
I'm trying to find the area of the shaded region. So I have 2 concentric circles. What am I going to need to find the area of first? My whole big circle. Then what am I going to have to find the area of? My little circle. And then what am I going to have to do with those 2 numbers? Subtract. Find the area of the whole circle, find the area of the small inside circle, and subtract the smaller inside from the larger outside. 25 is going to be just like we did in example 4, except we have a pentagon instead of a hexagon. 27, how am I going to solve 27? Yeah, I'm going to find the area of my whole square, then find the area of one of my circles, multiply the area of the circles times 4, subtract that from my total area of the square. All right, look at 29. It says copy and complete the table and round your answers to the nearest tenth. So it says,
Consider arc of the circle with a radius of 3.
Okay, so radius of 3, so area of corresponding sector. So if my radius was 3,
Plug in the values of the degree into that formula and just go up. Plug it in for Mark.
Mark's a legend. Mark is better than all of us.
Yeah, so for each one, the radius is 3. So the only thing that you'll be changing is mark, and you're finding the area, okay? So
Mark
just
will
change
never-
mark.
Mark will never change for anybody. He is his own person.
All right, we've got just a little bit longer. Let's look at 11.6, geometric probability. Don't you love probability?
No.
And that's your favorite.
The probability of outcome.
All right, so a probability,
25.
and I have a typo on your notes, 11.6, it should say a probability is a number, not if a number. A probability is a number from 0 to 1 that represents the chance that an event will occur. So if we're talking about probability, we're saying there's so many chances that this will happen. It is between 0 and 1 because a probability of 0 means what?
There's no option.
It ain't happening. Okay, probability of 0, there is 0 chance of it happening. What does a probability of 1 mean? 100% it's happening. Okay, so I go from it's not happening to it's definitely happening, and then my probability is somewhere in between there. Okay, so notice it says an event with a probability of 0.5 or 1/2 is smack dab in the middle. So there's equal chances that it will happen and equal chances that it won't happen. So when we think about rain probability, like if you're looking at the forecast and it's a 30% chance of rain, well, that means there's a 70% chance that it's not going to rain. So exactly. And then if it's Alabama, you can't go by that either. So it says in an earlier course, you may have evaluated probabilities by counting the number of favorable outcomes and dividing that number by the total number of possible outcomes. So like if you were going to reach in a bag of marbles and you've got red and green marbles and there's 10 marbles total and you know the whole deal.
I remember the marble.
And so reaching in and getting your marbles. Sometimes it's bad if you lose your marbles, but anyway. And so it says, in this lesson, you will use a related process in which the division involves geometric measures such as length or area. This process is called geometric probability. So in the green box, geometric probability with probability and length, it says if AB is a segment and it contains the segment CD. So we can see our picture, we have segment AB, CD is included in that segment. So it says if point K on segment AB is chosen at random, then the probability that it is on CD is as follows. So basically, my probability of point K being on CD, I would set it up to where the length of CD over the length of AB. So the length of the segment that I'm looking for it to be on divided by my total length. Okay. So then same thing with probability and area. If J is a region that contains region M, so we can see blue is the J region, M is contained in J, and it says if point K in J is chosen at random, then the probability that the region M is as follows, where my point in region M is equal to the area of M divided by the area of J. Let's look at example 1. Find the probability that a point chosen at random on RS is on TU. What is my length of RS? What is my total length of RS?
I have a question on that.
Okay.
So it looks like they're subtracting from the right to left because they have length to you. And if you subtract 7 from 5, it's 2 and 10 from 0. Did they do that?
Huh?
I don't know how they got 2. So I'm saying, are they subtracting from right to left? It looks like it.
Well, remember, we're talking about, like, if we're talking about number of distance on a number line, and I'm going from 0.5 to 0.7, how many places did it go?
Yeah.
And remember, distance can't be negative.
Yeah.
So this is where we're talking about absolute value. So basically, you could have 7 minus 5, the absolute value of 7 minus 5, or the absolute value of 5 minus 7. Because the absolute, that would be -2, which is still 2.
Yeah.
Okay, so my distance either way is still going to be 2. So my whole section or my whole segment RS is equal to 10, right?
Mhm.
So I have my segment of TU over segment of RS. So we said TU was 2, RS is 10. So that would reduce to 1/5. Okay, so then I would change that to 1%, and 1/5 is equal to 20%. So there's a 20% chance that it's going to be on the line. So is it more likely to be on the section TU or more likely to be on another section?
More likely to be on another section.
More likely to be on another section. There's an 80% chance that it is not going to be on that section. Goal 2 over on page 700. Using areas to find geometric probability. So we've got our dartboard. If you ever shot darts before or thrown darts, and you can see that the probability of landing in the outside areas is greater than the probability of landing on the little bitty inside area. Okay, so a dart is tossed and hits the dartboard shown. The dart is equally likely to land on any point on the dartboard. Find the probability that the dart lands in the red region. So I'm going to need to find the area of my red region and divide that by the area of the entire dartboard. So we can see that the area of the red region, my radius is 2. So I have pi times 2 squared. 2 squared is 4. And then my area of my larger region is going to be pi times 16. And so then I'm going to need to subtract.
I'm so mad at you on that. Like, guys, figure out the problem.
Yeah, you sat down there and calculate the probability. Okay, example 3, using a segment to find geometric probability. Transportation, you're visiting San Francisco and you're taking a trolley ride to the store on Market Street. You're supposed to meet a friend at the store at 3 p.m. and the trolley runs every 10 minutes and the trip to the store is 8 minutes. You arrive at the trolley stop at 2:48 p.m. What is the probability that you will arrive at the store before 3 o'clock p.m.?
Very high.
I know that when next time you go on a trip, you're gonna be like, I'm gonna calculate the probability of arriving by. So it says to begin, find the greatest amount of time you can afford to wait for the trolley and still get to the store by 3 p.m. Because the ride takes 8 minutes, you need to catch the trolley no later than 8 minutes before 3 p.m. or in other words, by 2:52 p.m. So you can afford to wait 4 minutes because 2:52 minus 2:48 is 4 minutes. You can use a line segment to model the probability that the trolley will come within 4 minutes. So you can see the number of minutes from 2:48 to 2:49 to 2:50, 2:51, 2:52. So you can see the time difference. You need it to come within 4 minutes. So in this, it says you're going to set your favorable waiting time, which is the 4 minutes, over your maximum waiting time, which is 10 minutes. So 4 over 10 reduces to 2 over 5. Remember, I can divide 2 by 5, and that will give me 0.4. 0.4 is 40% as a percent.
Just imagine getting there, do my probability of being 40%.
Totally miscalculated my probability. That's what I need to start telling people, is that's why I'm always late, is I incorrectly calculated the probability, my geometric probability.
Yeah, when you show up next Wednesday, you'll be like, I incorrectly.
Yep, I incorrectly calculated my geometric probability. All right, I will tell you that we will not test on this section.
No,
And
it's
actually-
fun.
Huh?
What? It'd be fun. It's easy.
Well, then maybe I can throw it in as a bonus. How about that?
Easton, just don't worry
So-
about it. It's not giving us a test. Don't worry about it.
What we'll do, let's take a look at our time. It is 10:05. We get out of here at 10:15. So we've got about 10 minutes. All right, so our homework is, I've already assigned 11:4, but then we went back and went over that last example on 11:4. So 11:4 and 11:5 will be homework. If you want to do homework for 11:6, I'll count it as a bonus. Okay, so you can make a note on your notes that 11:6 homework will be a bonus. So if you need bonus points for your homework grade, that would be an awesome thing to do. But if you don't want to do it, bonus wings. So anyway, so I will only test on 11:1 through 11:5. So test will be 11.1 through 11.5. So what we will do is next Wednesday, the first part of class will check homework. The second part of class, we will do chapter review. Okay, so first part of class, 11.4, 11.5 homework. Then we'll do our chapter 11 review on sections 11.1 through 11.5. And then I will give you the test next Wednesday for chapter 11. It won't be due until the next Wednesday, which is our last week of school. Okay. So the way that we'll handle that is it'll be due that last Wednesday. I will give it back to you on Thursday, our last day of class. Then you can choose to do corrections or not. You'll just need to make sure to email me your corrections, okay? And if you have any other corrections hanging out there, I need you to make sure to get those to me, because whatever corrections I don't have, your original scores are going to be entered into the system. So if you owe me corrections on any chapters, you need to make sure you get those to me next week.
Wait, so next week is our last week.
No, we have 2 more weeks.
And do my thing.
So next Wednesday, we will do chapter 11 review. I'll give you the chapter 11 test. Then we'll have class on Thursday. We're starting with chapter 12. Then the next Wednesday, we'll come back, keep on chapter 12. Your chapter 11 test is due. On Thursday, we will wrap up chapter 12. I will give you chapter 11 for corrections, and then you can email me those once class is out. Okay.
It's just your Alex so bad.
So we are on.
On Thursday. the last
Okay.
day.
Let me know if you have any questions.
Dude, Lucas.